All right, similar type of question. We're going to create quadratic equations from data. Now, we do have a picture here, and I'm going to superimpose a graph over top of it. Now, what we have in this picture, and I'm going to need to move the graph around, which is fine, is in volleyball, we have a setter, and it looks like this setter is the person standing right here. We'll show them with a stick figure also. So here's our setter. They can jump to set a ball, or they can stay on their feet. In this case, since we have in the background a net, we're going to assume she jumps up and sets the ball at the height of the net. Okay? We can move our graph for now to kind of correspond with that if we like. Okay, so that'll be our setter. Also in volleyball, there are 3 hitters. There's this person here is going to end up hitting this. I can't tell which is the middle. It's probably her. Okay, a person and another person who's going to hit out of here. The points that they're going to hit at, depending on how high they jump, are most likely going to be here. Here. Is blue no good? Sorry. Purple's worse. Okay. Maybe yellow would be good for. Oh, there we go. They're going to hit from here, here, and hopefully out here. These are the 3 spots they're going to be hitting from. Okay? So when the setter sets the ball in this game, and we're going to move our graph around, we'll even decide to move the graph so that the height of the net is the x-axis. Okay? When the setter sets the ball, it's going to loop. Okay? We'll call one of the sets will be a quick. So she'll set the ball and it'll roughly go this high and come back down here. There's another option where she'll probably set the ball a little higher and it'll come down here. And finally, the last option would be something like this. Okay? In other words, there are 3 types of parabolas the setter would need to set in order to properly execute an attack. So we've drawn our graph around these. We have a coordinate of where they're going to set from. It looks like this is the coordinate of 1. This would be 2, 3, 4, and so on. Go away. Okay. And this is on the x-axis, this one coordinate. So it looks like all 3 of these coordinates are going to intersect at this parabola are going to intersect at the same x-axis. That coordinate being 1 and 0. Okay, which is right here. Now, the hit is going to be obviously above the net. You don't hit a ball below the net. So the hit's probably going to be about a ½ meter above the net, something like that. So these seem to be the points of contact. Their y coordinates would be a ½ meter above the net. How far out would they be? Let's find out. This is at -2, -4, -6, -8, -10. This is for our graph. This is not in terms of actually how wide a court is, okay? 4, 6, 8, 10. So, from what we've drawn on here and on for our graph, we know the points of impact need to be around here. Now, because they're not exactly x-intercepts, what we're going to try to do instead is use vertex of the parabola to solve where this parabola, or the equations of the 3. So, from the first one, it looks like we go from 1 to roughly about 6, maybe 7. So halfway between that, the parabola's vertex is probably here at about 3.5. This is for the outside hitter. Okay? Their height is going to be, it looks like 1, 2, 3, this is 4. It's also at 3.5. That's the vertex to the ball on the outside. The ball to the inside, okay, looks like it's going to have a vertex roughly on, well, no, it wouldn't be on the y-axis because we're going from 1 to about -2. It'll be probably about 1.5. Okay? And the height of it, it will be 2. And finally, the one that lands all the way out here goes from 1 to, looks like about 9. So what would halfway between that be? Anyone know? 1 and 9? Probably looking around 4 and a bit, I would say. Probably about 4. And the height of it looks like it's going to be 5.5. So we're looking at 4. That's a bad color for that. 4 and 5.5. So what we now have are 3 vertex. These vertex will allow us to create 3 different equations for this question. Okay? So we'll zoom out a little. So, for the shortest set, the person closest to them, we know our vertex form is going to be y equals, we're going to have to solve for a. The x value was -1.5, so we're going to have +1.5 squared, and 2. The ball that goes to the right, y equals a. Our vertex is x minus 3.5 squared plus 3.5. And finally, the ball that goes to the farthest left will be y is equal to a, x, because it's negative 4, plus 4 squared plus 5.5. So, what we've done is put in our h and x coordinates from vertex form. We've used the vertex form to solve all of these, but we need to look for the a in these. We can use this same coordinate, find the a for all of them. We can use that x-intercept at 1 and 0 to be the x and the y value to solve for every single version of the a. So we'll just solve for one of them. Which one do you want to solve the parabola for? The smallest one? Okay. So the smallest one was the very first one we did. Good. Let's jump down. We're going to use this one only. Y equals a. We still need to solve a. X plus 1.5 squared plus 2. And our coordinates are x is 1 and y is 0. So if y is 0, we replace y with 0. A. X is 1 squared plus 2. From there, what is 1 plus 1.5? And then we have to do 2.5 squared. Anyone know what it is? Is it 6.25? Yeah? Okay. Probably. 6.25 plus 2. Now that's 6.25 times a. We can rewrite that as 6.25a. When we bring 2 over, it becomes negative, so we'll have negative 2 is equal to 6.25a. And then to isolate a, we need to divide by 6.25. Now remember, this is going to be a fraction with a decimal. Let's try to get rid of that decimal. This will be negative 2 over 6.25 equals a. What's another equivalent fraction of this? That would be a whole number on our denominator. What can we multiply 25 by to get essentially 0? 4. Very good. All right, so let's multiply the top of this and the bottom of it by 4 to get an equivalent fraction that would be just whole numbers. Okay. Negative 2 times 4 gives us negative 8. Who's got a calculator for the bottom part? I think it'd be 125. Yeah, I think it is 25. A is negative 8 over 25. So the equation of the smallest parabola would be negative 8 over 25. X plus 1.5 squared plus 2. So we're taking this value here, and we figured out what our a was, and we plugged in for it. Plus 2. Okay? So, if you're a middle hitter in volleyball, tell your setter you want that equation of a set. Okay? That'd be very specific.